question 2-3, we're going to be solving Trig equations. They're very similar to algebra equations. If you were able to do algebra 1 and solve equations there, this is very similar. Instead of solving for x, you might be solving for the sine of x. Just trying to get the sine by itself or the tangent or whatever. So if you look at this first one, let's say I had x plus radical 2 equals negative x. What do you think our first step would be? We would want to combine the x's. How would I do that? I would add x to both sides. So I'm going to do that here. I'm going to add sine of x to both sides. So these will cancel out. You're going to get 2 sine of x plus radical 2 equals 0. Again, our goal here is just to get sine of x equals. So I need to get the sine by itself. I'm going to subtract the radical 2 next. So those will cancel out. I'll have 2 sine of x equals negative radical 2. 2 sine of x is negative radical 2. We just want the sine by itself, so we're going to divide by 2. It's just algebra 1 skills. You just left the sine by itself. Negative radical 2 over 2. Now here's where it gets a little tricky. The sine of x is negative radical 2 over 2. What we need to find out is what does x actually equal? What could I put in for this x where it would make the sine come out as radical 2 over 2 or negative radical 2 over 2? And that's where you have to use your chart. So you're going to look at your chart. If you have your chart, you should take it out and take a look at it, because you're going to look down your chart. You're going to go down the sine column, and you're going to see where the sine is a negative radical 2 over 2. So as we go down the chart, we look down, we're going down the sine column. The first one I come to is at 5 pi over 4 radians. So that's one solution to this equation. 5 pi over 4 radians. 3 pi over 4 is a positive radical 2 over 2, so that doesn't work. We're going to go down farther, and we're going to see another negative radical 2 over 2 at 7 pi over 4 radians. So x could also equal 7 pi over 4 radians. Those are 2 right answers that I can put into these x's right here, and the 2 sides would equal each other. But there's an infinite number of answers to this problem. Because what do we know about our unit circle? We can go around the circle as many times as we want to, right? That means not only is 5 pi over 4 an answer, but all of its coterminal angles are an answer. So how would I write that on this? Is I would just do this. I'd put plus 2n pi. Now you probably know what 2 pi means. What is 2 pi on our unit circle? It's one time around. The n stands for what? What do you think? The number of rotations, however many times you want to go around the circle. So let's look at this answer on my unit circle. I've got 5 pi over 4 would be right to here, this spot. Okay, that would be this, from this part over to this part would be 5 pi over 4 radians. Now, I could stay here and I could go around one more time, and that would be another answer right to this spot. I go around again, that would be another answer. Every time I go around, it would be another solution. That's what this 2n pi is doing. It's giving me all the coterminal angles. So I could also add the 2n pi here. Now the n stands for the number of times I want to go around. If I want to go around once, 2 times 1 is just 2, and then 2 pi would just be 1 rotation. If I want to go around 2 times, 2 times 2 would be 4. 4 times pi, you'd have to add 4 pi to it, and that would be 2 rotations. So that's an n pi, 2n pi. Number of rotations. 2 pi is for the rotation, and n is the number of rotations. No, those are both right answers. It's like when you factor and you had 2 answers, like negative 5 and 4 could both be answers to the problem. It's like you've got 2 answers here that will both work. They will both make them equal. So either one you pick, you can put them in, it'll get an equal answer.
Just as long as they have.
As long as it's one of these two, or one of its coterminal angles would work.
Also, you don't have to put the plus 2 and 5.
Not all the time. Now, if it just says solve like this, then yes, you need the 2n pi.
Oh.
But on your little test from Friday, or your study guide, it gave you a specific interval from 0 to 2 pi. So you're actually only going to use the chart. So it makes it a little different. Yeah. 7 pi over 4, if you look down on your chart at 7 pi over 4, the sign is also negative radical 2 over 2. So both places, the sign is a negative radical 2 over 2 for both of these radians here. So that's two answers. Let's move to the second one so we can take a look at it. Let's solve for tangent. Let's just get tangent by itself. You gotta do what? In that last one, yes. You gotta find them both. That's 3 tangent squared x minus 1. So let's add 1. We get 3 tangent squared x equals 1. Again, we're just trying to get tangent by itself, so we need to get rid of that 3. So we're going to divide both sides by 3. So you get tangent squared x equals 1/3. Now we want to get tangent. We don't want tangent squared. We need tangent. So my next step would be to square root both sides. Now I'm going to square root all that stuff. So I have the radical 1 and the radical 3 on the bottom. And I'm going to get rid of the radical on the bottom by multiplying by radical 3 over radical 3. So you're going to end up with a tangent x equals a radical 3 on top and a 3 on the bottom. And you got to put plus or minus when you square root both sides. You're going to have that plus or minus in there. So that means that the tangent could be positive radical 3 over 3. Or it could be negative radical 3 over 3. So I think there's quite a few of those on this column right here. So if you look down the entire column, what are some of the answers that x could be? Where is it a positive radical 3 over 3 or a negative radical 3 over 3? 5 or 6 is the first one. X could also equal 5 pi over 6 would be the negative radical 3 over 3. Good. 7 pi over 6 would be another positive. And 11 pi over 6 would be the other negative. So I could write all 4 of those answers because they're all right answers. All 4 of them are correct. And I could add 2n pi because all of their coterminal angles are also correct answers. Now that's a lot of writing for that one problem, for that answer. We could actually shorten it up. And I'm going to show you. Take a look at these two. Look at the pi over 6 and look at the 7 pi over 6. How far apart are those? Okay, let me show you on here. Pi over 6 is here. 7 pi over 6 is down here. How far apart are those? It's like a half a circle, which is what? What is pi over, what is just a half a circle on my, it's pi. These are 6 pi over 6 away from each other, right? They're 1 pi. So they have a distance of pi. That means that instead of writing 2n pi for this pi over 6, I could take pi over 6 and just add n pi. Because what I did there is I combined these two answers into one answer. Because what would you get if you took pi over 6 and you added pi to it? What would you get? 7 pi over 6. And then if you added pi again, you'd be back to this coterminal angle. If you added pi again, you'd be back here. You'd just be going back and forth between these two every time you add pi. So it's just being able to take these two and making a shorter answer. These two are also a pi distance away from each other. So I could put 5 pi over 6 plus n pi. That would be a shorter answer. Now, is it wrong if I put all 4 of these and put those? No, it's still right. Those are all right answers. So those are all answers that I could plug in and would work, but it's shorter to put n pi because you can eliminate 2 of the choices that you have to put down. This right here covers both of these. This one right here covers both of these. So you would be done just with that. If it just says solve, then you got to write them all. If it says a specific period, like it's going to say on your test, then you can just pick the ones that are on your chart. So it just depends on what it says. This one, again, says solve. So solving means give me all the answers, all possibilities. Those are all the different possibilities that you could get. So that was example 2. Let me move to the next one. Got it?
I thought that was, I don't know.
No.
Yeah.
Okay, the next example, it looks a little different. Let me give you a second to write it down. This one has 2 trig functions in it. Normally, we would want to take one of those trig functions out, and so that all the trig functions are the same. But in this case, we could actually keep the 2 different trig functions in there and still solve for it. I'm going to show you how. Now, I asked first period and another period what would be a good first step. And a lot of them said, let's divide by cotangent on both sides. If you do that, it would cross out both of them, and you would be losing one of your right answers, because the cotangent would be gone. So we don't want to do that, because we'll lose our right answer. So we're actually going to subtract 2 cotangent x on both sides. That's going to get it equal to 0. Things are equal to 0, they're easier to solve, because something has to be 0 for them to multiply to get 0. Over here, you're going to get the cotangent x times cosine squared x, and then you got the negative 2 cotangent x that we just subtracted on both sides. Now here's the important step, and you're going to need to do this on your test. You're going to need to be able to see a GCF. Greatest common factor. What is a common, which one is a common factor here? Cotangent. They both have a cotangent of x. So take that cotangent of x out and see what would be left over after you take it out. You'd still have cosine squared, right?
Yeah.
So this cosine squared would still be there, and you would just have the 2. Do you remember if we had like 2x times x minus 3 equals 0? Do you remember how we solved that and got the 2 answers?
Oh. What?
Nope. We set them both equal to 0.
We did.
And we found the 2 solutions. Those are how you got your 2 answers. Well, that's what you're going to do here. This is going to equal 0. The only way that if you multiply these 2 together and get a 0 is that one of them had to have been 0 somewhere. So either this one was 0 or this one was 0. So cosine squared minus 2 equals 0. We set them both equal to 0, and then we just solve them. This one's already solved. Cotangent's already by itself. So what could I plug in for x that would make the cotangent become a 0? You got to look on your chart.
What? Oh.
You got to go down the cotangent column and find out where 0 is.
Pi over 2.
Pi over 2, also at 3 pi over 2. So I could write them both and then put a 2n pi after both of them to get all the coterminal angles. But tell me, how far apart are pi over 2 and 3 pi over 2? They're half a circle again. So I could save myself a little time and just put plus n pi, and that would cover both of them. That would cover the pi over 2, and it would cover the 3 pi over 2. So I don't need to actually write the 2n pi, I can just put n pi on that one, and it will cover all my answers. Now let's solve this piece. Add 2 to both sides. So you get cosine squared equals 2, but I don't want cosine squared. I just want cosine, so I got to square root it. So I get cosine of x equals plus or minus radical 2. Where is the cosine a plus or a minus radical 2? Keep in mind, radical 2 is 1.4 something. Where is the cosine a positive or a negative radical 2? It's not. Why can't cosine be 1.4? It can't be bigger than 1. Cosine has to be 1 or less. So this right here is no solution. Your only answer that you have for that problem is pi over 2 and 3 pi over 2, which you just add in pi and pi over 2 and you'll have them both. If you would have crossed out the cotangents, we'd have lost our answer completely. when you're square rooting both sides. That's when the plus or minus comes in. Okay, the next example is a lot like what you're going to see on your study guide and your final. Because the next example actually has the interval right here. And yours on your study guide actually says that as well. And that's actually much easier. Because now you don't have to add 2n pi or n pi. You don't even have to think about those. All you have to do is find the ones that are on your chart, and whatever ones they are, you got to list them all. You don't have to think about rotations or coterminal angles or anything. Just find out where the answer would be between those two. Now, this right here, let me rewrite it for you. I want to rewrite it like an algebra problem. So I'm going to put it over here as 2x squared minus x minus 1 equals 0. Do you remember how to solve something like that?
Yeah.
You could do that x or the star or whatever your teacher taught you how to do, right? But these are pretty small numbers, so we could probably just figure it out. How would I get a 2x squared? I got to have a 2x times an x, right? The only way I can get 2x squared. How would I get a 1 in the back? Got to be a 1 times a 1 to get a 1. How do I get a negative in the back? Got to have different signs. This first sign right here tells me this bigger one has to have the negative go with it. So when it's 2 times 1, this has got to be a negative. And that means the first one would be positive. And you can double check and make sure it comes out by doing FOIL. Make sure it's the same answer. So applying these two parentheses to this problem, what would my two parentheses be for this problem? Instead of 2x plus 1, what am I going to have over here? 2 sine x plus 1. But of x minus 1, I'm going to get sine x minus 1. Now you can just set them both equal to 0 and solve them. So you're going to do 2 sine x plus 1 equals 0, subtract 1. 2 sine x equals negative 1, divide by 2. So the sine of x equals negative 1/2. That's one solution. And this one, we're going to put sine x minus 1 equals 0. We're going to add 1. So sine x equals a 1. So where is the sine a negative 1/2, and where is it a positive 1? Those are going to be my solutions. And I don't have to add the 2n pi or the n pi or anything like that, because it just wants to know what answers are on your chart. From 0 to 2 pi, which ones are listed. So let's find the negative 1/2 first. Where's the sign of negative 1/2? 7 pi over 6, 11 pi over 6. And where is it a positive 1? Sign, positive 1. Pi over 2. There's your three answers. That's what x could equal. X could equal any of those three answers, and that problem would be correct.
So whenever we have like one of those problems where it gives you the interval, you always separate it into two.
Yeah, well, you don't always have to, because I only did that because this required me to factor it. It required me to make two parentheses so I could solve it. You might just have to take out a GCF and you can solve it. But you might not. You might get an interval, you might not. But on your test, you will have an interval. So you're just going to look for the ones on your chart. Just those. Okay, let's go to the fifth wheel. One left after this. This one's a little tricky because you've got sine squared and you've got a cosine. Could a sine squared become a cosine? Is there something I could put in for it that would make it equal? Identity's good. Which one is sine squared? Sine squared would be what? Close. 1 minus cosine squared, which might be kind of what you were saying, but you needed the negative cosine squared. So in this case, I'm going to put in 1 minus cosine squared. That's what sine squared equals. And then I'm going to bring down my 2. I'm going to bring down my 3 cosine. And I'm going to bring down my negative 3. So I just took this out and I wrote this in its place. Now how do I solve this? You've got to distribute first, right? Got to get this 2 outside here, distribute it, get 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. Then we need to combine our like terms. That 2 and the negative 3 are like terms. So you're going to get negative 2 cosine squared x plus 3 cosine x. And we have a 2 put together with a negative 3. That's a negative 1 equals 0. We can't really factor that down unless the first term is positive. How do I get this first term positive? Multiply everything by negative 1. That's going to change all my signs. So I'm going to have a positive 2 cosine squared. I'm going to have a negative 3 cosines. A positive 1 equals a 0. Could we factor that one down? I don't know if your teacher taught you the X or the star or whatever. I would show my students the star method because I think it comes out a lot easier. I would multiply the first number times the last number, that's a 2. My middle number would always go on the bottom, that's a negative 3. My front term, not the square part, but the front term would go here. Because that's what's going to be in the front of my parentheses. And then I got to find out what two numbers would multiply to give me a positive 2, add up to a negative 3. Negative 2 and negative 1. They got to both be negative. Now, can you reduce either of these fractions? The 2 and the 2. You could make that a 1 and a 1. So one parenthesis is going to be cosine of x minus 1. The other parenthesis is 2 cosine of x plus 1 equals 0. So let's see, cosine x minus 1 equals 0. We're going to add 1. So cosine of x equals 1. So we're going to need to find out where the cosine is a 1. Let's do that now. Where is the cosine of 1? At 0 and at 2 pi. So that means x is 0 plus 2n pi. I'm not going to just put 0 because it doesn't tell me an interval up there. So I actually need to write 2n pi. That means every rotation would also be a right answer. Start at 0, that's a right answer. Every time we go around, that's another right answer. So I'm adding 2n pi. So that's one solution down here at the bottom. Let's solve this one. Let's subtract 1. 2 cosine x equals negative 1 divided by 2. So we got to find out where the cosine is negative 1/2. Cosine is negative 1/2 at did I do that right? I knew I did something wrong. This minus right here is supposed to be in there. I knew there was something wrong. All right. Okay, so there's your plus. So this is going to be positive 1/2. So where is the cosine of positive 1/2? Cosine positive 1/2 at pi over 3. Also a positive 1/2 at pi over 3, right? Okay, so you need to add your 2n pi.
Sure.
Yep.
So you do it like on the start, you make it the count cosine x.
Yeah, when I multiply those two together, I'm going to get my squared term.
Oh, okay.
That's why I put them both up there, because multiplying those two gets me the squared.
Okay.
All right, last example. All right, it looks like this. Cosine plus 1 equals sine, and it wants it only in the interval from 0 to 2 pi. So only on your chart. We want the answers only on your chart. You don't need to add the 2n pi. You don't need to add the n pi or anything like that. But right now, I need to either take out a cosine or a sine so that they're the same trig function. You'll make it. You can write small, you'll get it. Can we take out sine and put in 1 minus cosine? Or does that only work for sine squared? Only works for sine squared, you're right. So we're going to need to square both sides first. Okay, so now here's where it got trouble last little period, is that they thought when they squared this, that it was just cosine squared plus 1. Now, when you square this, you actually get cosine squared plus 2 cosines plus 1. Because you're actually doing FOIL. You've got cosine x plus 1 and another cosine x plus 1. So you're going to do your outside, your first outside, inside, left. You're going to end up with 2 cosines in the middle. Because cosine times cosine is cosine squared. Then you got a positive cosine, you got another positive cosine, that's 2 positive cosines. Then you've got a positive 1. And it equals sine squared. But what could I put in the place of sine squared? 1 minus cosine squared would be the same as sine squared. So 1 minus cosine squared is what I'm going to put in its place. Now we got to get it equal to 0. Move the things from the right side over to the left. So I'll subtract 1 on both sides. What's going to happen to my 1s? They'll all cancel out. I'm going to add cosine squared on both sides. What's going to happen to my cosine squared? They canceling out? No, you're going to get 2 cosine squared plus 2 cosines equals 0. Do I need a star? Do I need 2 parentheses here? What? What can I do here? Factor, GCF. You're going to see a lot of those GCFs. You could take out a 2 and a cosine. So you took out the 2, you took out a cosine, you'd still have a cosine left. You took out a 2, you took out a cosine, the only thing you have left is a 1. Because 2 cosine x times 1 would be the 2 cosine x. Now you're going to break them both down equal to 0. So here cosine of x is negative 1. Here you divide by 2 and you get cosine of x is 0. So where on our chart would make the cosine a 0 and would make the cosine a positive or negative 1? Cosine is 0, pi over 2, and 3 pi over 2. So we need them both because we're just doing this one interval right here. We're not adding any n pi's or anything. So pi over 2, 3 pi over 2, and what would make the cosine a negative 1? A pi. There's your 3 answers. All right, so that is 2-3 notes.